This is video on statics of coplanar non-concurrent forces. This is 9th video in the series, and here we are looking at truss, solving it by method of sections, and this is video 2. So trusses which are a little difficult to solve by method of sections we are going to take up in this video. Okay, now just to revise method of sections, what exactly we are looking for is you are required to directly find force in a member of the truss without solving the truss fully. And the method consists of cutting the truss into separate parts, and for cutting the truss we are given some guidelines. One is member of interest must be cut, then truss must the truss must be cut in two separate parts, then one of the parts is considered for equilibrium calculations. As far as possible, we cut only 3 members and use sigma m equal to 0. If usage of sigma m equal to 0 is not possible, then we use sigma fx 0 or sigma fy 0. But suppose if truss geometry is such that you are required to cut more than 3 members, then we can only use sigma m equal to 0. Sigma fx equal to 0, sigma fy equal to 0 will not be of much use. So in this video we are demonstrating this last type. If truss geometry is such that you are required to cut more than 3 members, cutting only 3 members, truss doesn't get separated in 2 parts. So this is what we are going to look at. Let's see. Let's say I have a truss like this, and I am interested in this member which is marked out here. Now if I take any sort of cut, say 3 members, I can cut it, but it won't do me any good because sigma fx equal to 0 will involve these 2 members, sigma fy equal to 0 will also involve these 2 members, and sigma m equal to 0, if I take moment about b, all 3 will vanish and there won't be any equation at all. So one could try out some cuts, but finally either this cut or this cut works. So here, as you can see, I have cut how many members? 1, 2, 3 and 4. So this is the peculiar case where you are required to cut more than 3 members. Now let's say I have done that, and what I'm going to do then is take now you see I can only use sigma m equal to 0, so I have to choose the right point. So I have chosen sigma mc equal to 0. See the advantage, this force which is, this member which is cut passes through C, this member which is cut passes through C, this member which is cut passes through C, and this member of interest doesn't pass through C. So only one member will appear in the equation. Have a look. So that will be, and I'm taking upper part of the truss so that I avoid working out of the reactions. So that will be minus 15 into 4. See this 15 and this 4. Then minus 15 into 2 is this 15 and this 2. This 15 is passing through it, and then FBE, the member of interest, into 4. All give clockwise sense, so all are negative, and I get in one step FBE comes up to minus 22.5 kilonewton. I assume with this tension it will be towards the section, so the nature is compressive. So this is how we have done it, of course in one equation in one step, but taking the section was a little bit skill was involved, and we were required to cut more than 3 members. One more problem on this. Look at this problem, and I am interested in KL. You could try out various cuts, won't work. After few trials you will come up with a cut like this. Now let's say I take up this cut, and let's first work out reactions. So those will be sigma fx equal to 0. If I take, I will get p plus p and plus hj. I will assume hj in the positive direction, so hj comes out minus 2p. Then I take sigma m equal to 0 to work out Vj. So that will be P into 3D, then P into 2D, and this Vj, which I assumed it to be up into 2D, I get Vj also as negative. So Vj and Hj, the reactions at J are worked out. Now let's take the left part of the truss and let's take moment about B as 0. Now what happens if I take moment about B? This member which is cut passes through B, this member which is cut passes through B, this member which is cut again passes through B, this member which is cut also passes through B, but this member which is of interest doesn't. So you will get answer for Fk in one step. Have a look at the equation. It will be Hj into 3D minus Vj into D plus Fkl into 3D, Fkl into this 3D. Put the values and here you get your Fkl, which comes to 1.167 P, and it comes positive, so it is tension. So again you see one right cut and one equation, and you can work out. See, otherwise solving this would have involved solving of so many members. So to that extent you have saved a lot of labor and got your answer immediately because you are only interested in one member. So that is method of section incomplete. Thank you.